Hello, and welcome to today's webinar, Pulse Policy Secure Intelligent Access Security. My name is Craig Sorois, and I will be your host for today's presentation. We will take Q&A towards the end of today's call, but you will be able to submit your questions at any time by clicking on the Questions tab and typing your question into the box. Now, I would like to turn the presentation over to Pulse Secure Principal Solutions Architect, Lisa Lorenzen. Lisa?
Thank you, Craig. So we're here today to talk about Pulse Policy Secure and the origins of this solution and how it can benefit end users who are looking for a variety of different solutions in their environment. There are a number of reasons that you might look for NAC or access control. And one of the biggest ones is the rise of the mobile workforce. So I'm actually the poster child for this, in that I have a laptop, multiple tablets, a cell phone, and no desk. I'm a teleworker and a traveler, and I connect to my organization primarily from personal devices, from mobile devices. I can't remember the last time I had a desktop PC at work. So this has really changed the face of connecting to enterprise resources, because the mobile devices obviously can come in from anywhere, both externally and internally, and are often less controlled, and in the case of the mobile operating systems, less controllable than the legacy PC operating systems. Another reason that access control can be desired is to balance the ability to secure the data and the networks in an organization while being able to allow users to work in the way that most benefits them, to be most productive and access the information they need from the device they want. And the third big driver for access control is, of course, compliance. There are a variety of different regulatory bodies and regulatory frameworks that require the ability to control who accesses data and how that data is protected. And the regulatory frameworks almost invariably come with some kind of audit requirement. So being able to not only protect your data, but to prove to an auditor that you're protecting your data is a big driver for what we call mobility-ready secure access. So mobility-ready secure access delivers comprehensive visibility, the ability to see what's on your network, to understand what types of devices, what types of users, what types of information they're accessing. Once you have an awareness of what's happening on your network, that gives you the context that you need to build comprehensive access control policies. These can be based on who I am, what my role is in the organization, where I'm coming from, what type of device I'm on, whether it's a corporate or personal device, whether it's compliant with corporate policies. And so this allows the granular control of both corporate and personal BYOD devices. And of course, when you talk about BYOD, you have the challenge of handling devices with all sorts of different operating systems you can't necessarily have the same degree of control over, but you still need a way to integrate them into your environment. So the automation of that type of onboarding and enrollment is really critical. So if you roll back the timeline to the early 2000s, this solution really began with remote access. The early 2000s were a simpler time. If you had a corporate network, you had a firewall at the edge of the network, and you basically assumed that everyone in your network was trusted and everyone outside of your network was untrusted. But you needed some way to give teleworkers and home workers and contractors and business partners access into your network, and this is how Pulse Connect Secure came into the picture. So Connect Secure started life as the Neoterras SSL VPN, and it gave granular role-based access control so that you could identify whether it was a home PC, a mobile device, a laptop, etc., allow them to come in through the gateway, either a physical appliance or a virtual appliance, and provide access to resources inside the network. Gave a high level of visibility into who was accessing from outside the network and what types of applications, what types of traffic they were sending. Our customers came to us and they said, we're really happy with this solution. We like the ability to do granular role-based access control, and we want to extend it to our internal users as well. So can we just take the SSL VPN gateway and flip it around and point it inward? But unfortunately, you can't really do that for a couple of different reasons. So if you have an SSL VPN gateway, it's usually at the edge of your network, and it's always an in-band solution. It's passing traffic. So if you desire to get access for your internal resources, for wired and wireless devices that are accessing resources, you can see the problem here. We're not in-band. And it's really unrealistic to put an SSL VPN gateway between every internal resource. So we looked at this problem and we said, okay, we could take the policy engine from the SSL VPN gateway and we could break it out into a separate entity. And that's really how Policy Secure was born. So Policy Secure itself is a policy server that leverages the granular, context-based role assignment and the ability to provision resource access policies. But that's where it gets interesting because provision them to what? On the SSL VPN device, you're either doing web rewriting or basic web application access or possibly a layer 3 tunnel, but all the traffic is passing through the box. In a corporate environment, you don't necessarily have a single choke point, and you definitely have higher bandwidth connections. So we needed an intelligent, dynamic, and fast way to do enforcement inside the network. And this is where we looked to our firewalls for a solution. So at the time, we started out with the NetScreen devices, the ScreenOS firewall, and we enabled Policy Secure to push down resource access policies to these firewalls. So you had the ability to authenticate a user using an agent or a web portal, and now you can associate the IP address of the endpoint with the user's identity and role by checking against your backend AAA data stores like LDAP, Active Directory, RSA, certificate-based authentication, etc. Once you've identified who that user is and what role they're in, then you can push down information to a firewall that enables that firewall to do an intelligent, identity-based access decision. So you can have some security policies on your firewall that are traditional security policies just based on source, destination, and service. And these could be for infrastructure resources like DNS and DHCP that are really required to bootstrap the connection into the network. But once that user has the information they need to connect to the network, if they actually try to access resources on the network, that access decision can be based on their identity and their role rather than simply based on what subnet or IP address they're coming from. So firewall-based enforcement is a great solution for something like a data center edge or the perimeter between a more trusted network and a semi-trusted or untrusted network. But it doesn't really scale out to every device and every connection. So our customers came to us and they said, this is great, we want to expand it again. Can we push this all the way out to our edge of our network? And the answer there was that we bought a company called Funk Software. And Funk Software gave us steel-belted Radius, which was the industry-leading Radius server. And it also gave us the Odyssey Access Client, which was an 802.1x supplicant that was fully centrally configurable and manageable. So with that, we got the ability to communicate with any Layer 2 switch or access point for 802.1x so that we can now take these devices and when they touch the network for the first time, we can authenticate them. We can do a posture check of what type of device it is and the health of the endpoint. We can use all of that information to map them to a role. And now we can provision access requirements down to the switch and the AT, as well as to the firewalls in the environment. So that solution is standards-based, and it works with any enterprise-class network edge infrastructure that supports 802.1x and Radius. We've also done some customization for wireless networks around guest use cases, where you have common wireless deployments like Aruba and Cisco WLAN, and we can integrate with their existing captive portal for allowing users onto a guest network and capturing information about them. Now that we have these enforcement mechanisms, one of the questions is, this is all great as long as I have an end device that can run an 802.1x supplicant or a Pulse client that will allow the end user to authenticate themselves or the end device to at least provide some information. What happens for unmanaged devices? Printers, voice over IP phones, IP-enabled security cameras, sort of the dark matter of the enterprise. And the answer there is we have the ability to integrate with industry-leading profiling solutions both our own Pulse Secure profiler, which is launching this fall, and also with Great Bay Beacon software, to identify and build a database of these unmanaged devices on the network and assign them to profiles so that they can have the same type of access security applied to them, and in some cases, the same types of Layer 3 enforcement available as well. So we've built an infrastructure for controlling access to the network and also through the network. Now we want to watch what people are actually doing. So let's say that I have a corporate device that is compliant with security policy, and I have authenticated to the network, and my identity and my group membership associate me with a certain role that allows me to access particular resources. Everything's cool, right? I can do whatever I want. Maybe not. If my device is compromised, maybe by a zero-day vulnerability, or if for some reason I am attempting to perform an activity in the network that's unauthorized, it would be really helpful to be able to observe that behavior and tie that behavior back into the access control decision. And so this is where we leverage a set of industry standards for security automation that allow us to receive behavioral data from other elements in the network. So these could be, for example, a SIM like Juniper STRM or IBM QRadar. It could be the behavior monitoring components of the existing Great Bay and Pulse Secure profilers. Could be other IFMAP sensors that are signaling things like location or activity in the network, a vulnerability scanner, etc. What all of this allows us to do is gather information from third-party components in the network and use that behavioral information to modify an access control decision. And we'll see an example of how this works later when we walk through some usage scenarios. The other benefit that we get from implementing this security automation standard is that we now have an ability to tie together our SSL VPN and NAC authentications and policy enforcement. So if I personally connect to my laptop using the Pulse client to log into the corporate network, and I then want to access a resource deeper in the network that's protected by a firewall enforcement point, there's really no reason for me to have to go through the same authentication and authorization process twice. Ideally, once I've been identified and mapped to a role by the SSL VPN gateway, the policy server should be able to leverage that information. And using this IFMAP security automation standard, we can do exactly that. So we're now able to federate user sessions from the SSL VPN to the NAC policy server, and also between multiple policy servers that might be distributed over a wide range of geographic areas, like multiple cities in a particular region, or even multiple theaters for a global deployment. So seamless single sign-on becomes possible for users connecting outside the organization, users connecting inside the organization, to access resources that are protected by this internal network segmentation. And of course, the next big thing that happened was mobile devices. So now instead of desktops and laptops, we have desktops, laptops, tablets, and smartphones running different operating systems and basically pretty much glued to people's hands as far as I can tell. I spend more time answering email and accessing internal resources from my phone these days than I do from my laptop, which is a little terrifying when you think about the workout my thumbs must get. So clearly, I want to be able to use these devices to have the same access to resources and to be able to do my job. And it's in my organization's best interest to allow me to do this. So we started to integrate mobile devices into this solution. And one of the mechanisms that we use to do that is integration with some of the leading mobile device management solutions, like Mobileye and Airwatch. So we now have the ability to use them as an additional back-end data store to augment the information we get from the Active Directory or LDAPs of the world and the profiling data. So we can now do device classification to say, is this device a corporate managed device? Is it compliant with MDM policy? Or if it's not in the MDM, maybe we want to push that through some kind of onboarding process to allow a user to bring a personal device that will continue to be unmanaged, but we want to give a limited access to the resources. So we've built this fairly comprehensive network of interconnected systems all talking with each other. And the thing to note here is this is a really extensive set of flexible solutions under one umbrella, but there's nothing that says every single piece of this is required. So I think of this as my toolbox. When I look at an enterprise security challenge, I think which of the tools in this toolbox are relevant to that challenge. So there may be some environments where the only thing you need is admission control and the ability to profile and identify what devices are connecting to the network. There may be other environments where the primary focus is BYOD, and you just want to allow mobile devices onto the network and tie back to an existing MDM. Or there may be cases where the priority is protecting sensitive data in a data center, and so a layer 3 enforcement solution with firewalls for network segmentation is the preferred deployment option. And these can be layered on top of each other for defense in depth, and they're definitely something that you would want to roll out as a series of targeted steps as opposed to trying to peanut butter the entire solution across an entire organization. So now that we've built this solution, what can we do with it? Well, the primary and fundamental goal is visibility. You can't control what you can't see. And most organizations are always looking for better awareness of what's on their network, what kind of security policies they need to apply, what's happening when you have an incident or an unusual circumstance in the network, and how do you demonstrate to an outside party like an auditor that you are controlling the network in the ways that are required. So visibility is really the baseline. It's the layer 0 of any kind of enterprise security deployment. Once you have that visibility, then another huge driver is secure mobility. The ability to centralize policy across all sorts of devices, personal devices, corporate devices, wired devices, wireless devices, and allow users to go back and forth between the internal network and remote access with as simple and as transparent an experience as possible. So really it comes down to the policy follows the user, and that user may have different types of access depending on whether they're on a corporate device or a personal device. There may be some resources that can only be accessed from a secure facility versus a semi-trusted part of the internal network versus remote access. But you have the ability to assess who your user communities are and how they will access resources and apply these controls. Another big driver is regulatory compliance, where we have the need to prevent unauthorized data access and protect the network against compromised systems, apply strong encryption, and then prove to one of the various auditors that you're actually doing all of these things. And the cornerstone for that is comprehensive access control, context-based, intelligent access control decisions, so that you can assess the combination of a user's identity, role, device, compliance status, location, and behavior to determine where they can and can't go. So how does this look in the real world? We've got a few usage scenarios to show what the end user experience would be. The first one would be across the 2 different enforcement modes, showing the 802.1x layer 2 admission control and also the non-802.1x layer 3 network segmentation. So this usage scenario is for basic access control enforcement, and it's an environment where you have both an 802.1x capable switch and a firewall enforcer. So a user connects to the network and they're running a laptop. So they stuck it in a drawer for a week and went on vacation and it didn't get patched. So they log in from this unpatched device. They bring it in, sit down at their desk, connect to the switch. And the environment determines that the laptop is not up to date. So you might quarantine the user and put them in a management network where they can only access patch remediation. Or more realistically, you might just kick off the updates on the device while the user is allowed to continue to do their job. In either case, once the device is remediated, then the end user has full access to all of the resources on the network. So the policy server is going to push down ACLs, VLAN settings, possibly even advanced topics like quality of service settings down to the switch. And it's also going to deploy authentication table entries and resource access policies on the firewall to enable role-based policy enforcement deeper in the network. The end result is the end user is allowed to access the data that's appropriate to their role, but they're not allowed to access data that would be protected or not available to them. So this is sort of the building blocks of an access control deployment. Now what happens if you have a headless device? You've got an endpoint profiler running in the environment, and it's watching everything that's going on. You can feed it SNMP, NetFlow, DHCP, all sorts of different information to enable it to build a picture of all the devices and, more importantly, get an idea of what they are. So once you have this, when an unmanaged device connects to the network, the switch can do an authentication lookup based on its MAC address. So Policy Secure will then query the profiler to say, hey, what is this MAC address? Have we seen it before? If it hasn't been seen before, then the profiler can start to gather whatever information is required, and it might be assigned to a guest or an untrusted access role. If it has been seen before, then the profiler will return enough information for Policy Secure to map it to a role. And at that point, it gets the same types of access enforcement that a regular device would, what VLAN, what ACL, etc. So now let's say that I come in and I flip over your printer, and I clone its MAC address onto my laptop. When I first connect that laptop to this switch, the profiler isn't going to know any different because all we're doing is a MAC lookup against the existing profile data. But as soon as I start to do something that a switch wouldn't do, like, say, nmap the network, the profiler can detect that the behavior is no longer compliant with the profile for that type of device, and it can remap that device to a new profile. So you have both initial admission control, but you also have spoof detection and the ability to apply a greater security policy. So now I might bounce the port, require reauthentication, all based on this security automation that I received. So the profiler detects that the device is no longer in compliance with its profile, reassigns it to a new profile, and generates an IF-map event, this security automation signal. And then based on that security automation signal, we can take whatever necessary action is required to restrict it, to kick it off the network, or, you know, if you're concerned that it might be a critical system and a false positive would be a big issue, you also have the option to log it and not take any enforcement action, wait for an administrator to intervene. The third case is the user federation that I talked about for seamless NAC and remote access. So if I connect in through the SSL VPN, and again, I might have an unpatched device, I get quarantined. So now in this case, it's the SSL VPN that's doing the quarantine and encouraging the remediation. Once my device is compliant, then I get access through a layer 3 tunnel through Pulse Connect Secure. And now I try to send traffic through an internal access control device. So again, we have the ability to federate that user session where the Policy Secure looks up the end user IP address in the federation server. Federation server was populated with that information by the SSL VPN, and the end result is Policy Secure is able to provision access through the network segmentation device exactly the same way that it would have if I had come in and authenticated the policy server rather than the SSL VPN. Finally, you have the model for coordinated threat control. And this is the case where we're interested in the behavior of the device on the network. So you have an infrastructure device accessing the network, and it attempts to do something unauthorized. So it's trying to access a protected resource, or it's sending traffic that's unexpected. And in this case, that network sensor, this could be the behavior monitoring in the profiler, it could be the trigger set up in a SIM. It detects that unauthorized behavior. And so that network sensor is able to signal, again, through that security automation interface, the behavior change to the policy server. So we have the same model that we did for the unauthenticated devices, but this could really be applied to any device in the environment. Again, Policy Secure correlates the information and decides that this thing needs to be remediated or that access needs to be changed on the network. So Policy Secure offers a multi-vendor solution based on open standards and able to integrate with any existing infrastructure. You get context-aware policy enforcement for wired and wireless connections, inside and outside the network across a range of platforms, and both at the edge and deeper in the network. And it enables access control, BYOD integration, and applies to any type of device. So are there any questions?
Thanks, Lisa. We have a couple in queue here. Just a couple minutes left in today's call, so I'll get to these. First one up. Do businesses usually utilize firewalls or 802.1x or both? And how do they decide?
Oh, that's a great question. So in many cases, the decision will be dictated by what exists in your network. If you have a Juniper firewall or a Palo Alto firewall, then the network segmentation can be an easy initial step towards an NAC deployment because you already have the enforcement point in place, and all you're doing is adding the intelligence to make that an identity-enabled enforcement point. On the other hand, there are lots of environments where that won't be available, and so the approach would be more based on admission control. And in that case, you would probably start with something like a wireless network because it's a simpler use case. You're likely to have fewer unmanaged devices. So you could start with a wireless 802.1x deployment. Often that'll catch the majority of your BYOD devices. And then once that's well understood, extend it to a wired 802.1x deployment as well. So it's really a question of both what problem you're trying to solve and what existing infrastructure you have in your network.
Great. Next one up. I hear NAC is complex and difficult to deploy. What makes this any different?
Thank you, Mike Fratto. So a NAC deployment can be intimidating because touching every port on every switch to turn on 802.1x can be a big challenge, or taking the risk of adding an extra step to the firewall that is controlling business traffic that enables everything your company does can really seem like a big hurdle to overcome. So there are two things that organizations can do to ensure success in this kind of access control deployment. The first one is to break it into very manageable chunks. So again, start with wireless, then move to a wired network, start with a pilot environment, and then expand it to a greater geographic territory. And the second is to start in an audit mode and go for the visibility first. For all of these technologies, you can start off not doing any active enforcement, but just information gathering and showing what would have happened. And that allows you to learn about your environment, to understand what will happen when you do turn on the enforcement components, and to really ensure success by starting with tackling the low-hanging fruit, doing it in as conservative and safe a manner as possible, and then migrating through each step of your deployment process once the previous step is well understood.
Great. And Lisa, we have one more question in queue. The final question is, why can you work with any vendor switch or AP, but only Juniper and Palo Alto's firewalls?
That's another good one. So the simple answer is standards. 802.1x and Radius standards are well adopted by edge infrastructure. And so because we have the ability to leverage those standards, we can work with any switch or any access point that supports them. And then the problem with firewall enforcement is that most firewalls don't implement 802.1x or Radius, so we don't have a standard way to communicate user information or access control lists. So it ends up that you don't have a standard way. We have to do custom integration with each vendor using their APIs or a proprietary protocol.
Great. Thanks so much, Lisa.
So it looks like we're about out of time. I would like to invite everyone to join us for the next in this webinar series. We'll be doing a deep dive into the Layer 2 enforcement options and how to successfully deploy that and manage it in phased deployment.
Great. Thanks, everyone, for attending today. Have a great day.